Okay, this is going to help you understand some of the important trig values using radians. Let's just remember how we generate these. Just remember our equilateral triangle, which has got 2, 2, 2. Cut that in half, that's 1. So that's 60 degrees, which is pi over 3. Half of 60 degrees is pi over 6. So we can remember 2 squared minus 1 squared is 3. So this is root 3. Don't need this anymore. Okay, let's use the triangle to help us a bit. Sorry, it's a bit scruffy. Here we go. So sine of pi over 3, opposite of a hypotenuse, is root 3 over 2. Sine of pi over 6 is 1 over 2, a half. So there you go. Cos of pi over 3 is opposite, adjacent over the hypotenuse. Got half. Cos of pi over 6, adjacent over hypotenuse, we've got root 3 over 2. Notice how these angles, which complement each other to make pi over 2, 90 degrees, have the same value. Let's have a look at tan. Tan of pi over 3 equals pi over 3, opposite over adjacent, so it's just root 3, and tan of pi over 6 is going to give you 1 over root 3, or better, I suppose, root 3 over 3. All right, so let's have a look at the other triangle we use. 45 degrees. Oh, start that again. It's not much use, is it? Isosceles triangle, I've got 45 and 45, which is pi over 4. I do tend to refer back to degrees, just helps with your fluency so you can picture what you're talking about. So they're the same, we'll call them 1. 1 squared and 1 squared is 2, so that is root 2. So sine of pi over 4 is 1 over root 2. Better, root 2 over 2. Cos of pi over 4 is, again, 1 over root 2, according to the diagram, which we can write as root 2 over 2. And tan of pi over 4 is 1. So those are our key values. We know those in degrees, but we need to be able to work them out in rads. Okay, let's look at how we use our knowledge a little bit. I'm going to deduce the value of cos 5 pi over 4, just using what I know and a graph. That's a cos graph. There's pi. There's pi over 2. There's 3 pi over 2, 1.5 pi. We're looking at 1.25 pi, so it's going to be about there, where it's going. So there's 5 pi over 4. helps to translate what this is all about. So these are going to be the same using my symmetry. That would be 3 pi over 4. So I'm a quarter in from there, quarter pi in there. I go quarter pi that way, I get pi over 4. Now, that value, whatever that value is the negative of whatever this value is. I understand the symmetry of the graph. If you understand it too, you can work these out. So what that means is that's negative cos of pi over 4. Well, what is pi over 4? Cos pi over 4. Well, let's remember, it's negative lots of cos of pi over 4 was root 2 over 2. So it's negative root 2 over 2 is my answer. So I'll just write it down here. Cos of 5 pi over 4 equals negative root 2 over 2. Let's just review what we've done there. Let's have a look. 5 over 4 pi, 5 pi over 4 is there. 3/4 pi is there. We're just looking at moving in pi over 4. So if I go back pi over 4 from a half pi, I've got pi over 4. I'm using the symmetry of the graph. Get yourself on Desmos, look at the graph, look at the symmetry, look at where the values meet, and that will help it come together. Okay, let's have a look at sine 7 pi over 3. I'm going to draw a graph of sine. That's not quite as bad as my normal attempts actually on here. There is pi. There is 2 pi. And 7 pi over 3 is a bit of a 2. In fact, I've just got here pi over 3. So, well, what's this value? This value here has got to be the same as sine of pi over 3. Just looking at the pattern of the graph, sine of pi over 3, it equals sine of pi over 3. So let's put that in. Well, remember from our previous triangle work, sine of pi over 3 is root 3 over 2. So these are all about looking at the symmetry, looking at the pattern of the graph. Good understanding of your trig graph is helpful, even when it's drawn badly like mine. Thank you very much.